Hi guys, in this video we will be discussing in detail about a data type called set in Python. Uh, Also, we will be covering what are the operations or methods that we can perform on set. In addition to that, we'll also discuss what is a frozen set. It is also another variation to set in Python. So let me define a simple variable called fruits. Um, as you can see here, there is a curly sort of braces here. And basically, it's like if you are representing anything in between curly braces using a comma separated values, then that is what would be classified as set. So if I print that set, and then let's say I also print the type of that particular set, you would be able to see that it belongs to set, and then this is how it would get printed as well. So set is basically unordered. So at a given point in time, it can have any order, and therefore you cannot really have a control over it. And another main important aspect is it will never have a duplicate. So what I imply by that is like, imagine that I add one more fruit called as orange here. Then although I added orange here, but you can see there is only one orange that got printed here. So set would allow only unique items to be, utilized or present in a given set. So this is quite useful in the scenarios where you want to eliminate duplicates, that are part of a list, for example, and then you want to perform some operations on those values. That's where set comes into handy. Now, let's say you want to initialize a set, right? Now, if you are initializing a set, let's say I want to initialize a set called fruit, and then if I initialize it like this, then it is going to treat that as a different data type. That data type is called as dictionary. So let me show you what I'm talking about. I'll write it as fruits rather. So you cannot initialize a set like this. So you should rather initialize set in this fashion. So you should call a method called set, and then if you basically initialize that set, then that would be treated as a set. So this is here the only way with which you can initialize a set that is empty. Yeah. So please do keep that in mind. Now imagine that you have a list of items, and you want to initialize a set, then also this is handy. So let's say I want to initialize a list of set items, then what I can do is like, let me convert this into a list by specifying the square brackets here, and then let me present it like this, and then print fruits here. Now, because all the list had duplicates, it was intelligent enough to remove those duplicates, and it gave us basically the list of values that are sort of unique. Likewise, you could also pass a tuple to set. So instead of square brackets, let me put the parentheses here. And then, as you can see, even the duplicates in the tuple were sort of removed with the set. Yeah. So this is how you would be defining set. These are the different variations in which you would be initializing an empty set or defining a set that has got values. Yeah. Now let's go to the operations that we can perform in a set. So imagine that I have two bags. Bag one contains apple, orange, and kiwi. Bag two contains a dragon fruit, banana, and kiwi. Yeah, you you can see that bag one and bag two have one fruit in common, that is kiwi. Now I'm I, I'm not sure how many of you are aware of Venn diagrams. The first two that we are going to discuss is similar to that operation in Venn diagram. So union is going to combine this bag one and bag two and produce a set that includes list of all items that are available in bag one and bag two by eliminating the duplicates. So let's say I have bag underscore union that I want to create, and then I'll simply say bag one, and I use this pipe operator and specify bag two. Let me print bag underscore union, you can see that only one kiwi is there and the other kiwi duplicate got removed successfully. Now, intersection is whatever that was common between these two, or that is a match between these two, only that would be printed in the intersection. So, what I imply by that is like, let me copy this and then paste it here. And in place of union, let me type it as intersection and then update it here. And with it, for the intersection, you use this operand, which is ampersand operand. And then if you do that, it returned me a set that had only common factors or items in that particular set, that is kiwi. Yeah. Now we have a bag underscore difference. Now what it does is like, let's say if I use bag one minus bag two, uh, and then I print the bag underscore difference, you see that I'm actually, considering these two sets, bag one and bag two, and I'm sort of, when I apply these changes, it's going to return me only the items that are available in bag one, but not available in bag two. So what I imply by that is like kiwi is sort of available in bag two, therefore it is disregarded, whereas apple and orange is available or are available only in bag one, and therefore it's sort of returned. Now if I do the vice versa and say bag two minus bag one, I guess you guys might have guessed it. It is going to return dragon fruit and banana and remove the kiwi. So if I type, execute that particular cell, you can see that it sort of returned me with a set of bag one. I mean with a difference of bag banana and dragon fruit. Now there's also a thing called symmetric difference. So let me type bag underscore symmetric and say bag one, and I will use this operand and say back to, and let me do bag underscore sim. You can see that it returned a set of items where there are from both the sets included without any common items that are part of it. So what I imply by that is like kiwi is the only common factor between these two sets. So it totally disregarded in the symmetric difference, and it just returned apple and orange, apple from bag one, and dragon fruit and banana from bag two, and then made it as a single set. So this is how where you would use a symmetric difference. Now let's take a look at the other method, which is disjoint. Now what imply by that is like if I use print bag one dot is disjoint bag two, it's going to return me false. That is because Kiwi has a matching factor of, Kiwi is sort of present in both the sets. Therefore, it's not a set which is sort of totally unique. So with this disjoint, imagine that you are using it in the if statement where you want to execute or identify if bag one is totally a unique set compared to that of bag two set. Then that's where you would get this one quite useful. So let's say I re-execute this cell, and therefore now bag one is sort of initialized with apple and orange only, whereas bag two is got all these three. Now if I print this, and let me just also to show you guys print bag one as well. Now you can see that it immediately changed that to true because it only has orange and apple, and there is whatsoever no correlation between bag one and bag two, and therefore it returned that as a true. Now let me add kiwi back for our uh, discussion point of view. So that's the beauty of disjoint. Now let me print bag one again here, and what we're going to look at is few other methods, which is add. Now, if I say I want to add an item to this set, then I will use the add method and say I want to include strawberry. As soon as I do that, now bag one would get modified and it's gonna include strawberry as well in that particular set. Now, if I want to add more than one item, I would use a method called update, and then I think I can also initialize a new set. For example, fruits underscore temp, and then I have a fruit called watermelon, and then I have a fruit called, let's say, Um, anyway, dates. I hope date is a fruit, but yeah. So if I do that and say fruits underscore temp, and then let's say print bag one. You must pass a set here. If you pass individual characters and all, you are already aware that it's always going to treat that as separate characters. So if I print that, you can see that watermelon and dates also got added to it. So what I imply by not including an individual word or single word is, for example, imagine that I have a fruit called, I have something called as characters is equal to set, and then I specify banana here, and if I print characters, you can see that it printed me only with the unique values out of that particular word, and only gave me a 1a, 1b, and 1n from it. That's why you have to be mindful when you're sort of passing values and sort of operating between, in general in words in Python. You have to be very cautious on how you deal with those, methods and operations. Now we will use copy method. I want to clone this from, let's say now this is bag one, right? If I print bag one here, this is bag one. And if I print fruits underscore temp, you can see that fruits underscore temp only has these two things. Now I'm gonna basically create a copy, a fresh copy of bag one onto fruits temp. So that's what I'm gonna do. So what I will do is like fruits underscore temp is equal to bag one dot copy. So when I do that and let's say I print fruits temp, you can see that from this particular set, it totally got modified. It created a copy of bag one, basically this set, and then sort of assigned it to fruits temp variable. So that is how you can create a copy of the set without modifying the original set. Now we will look at clear, remove, and discard items. So now if I want to, completely wipe out all the items in that particular set, then I use clear, so similar to that of a list. So if I use clear, and then if I print fruits temp, then it's going to return me an empty set. So clear is going to completely remove all the items. So let me reinitialize that fruits temp here. And then basically I'm gonna use an operation called remove. So now fruit stem dot remove, and I want to remove a value from that particular set. Let's say I want to remove apple from that set. So this is how I would pass that. And if I print the fruit stem, oh, sorry, I need to print fruits temp. You can see that I removed apple from the fruit stem, and that's why you see dates, kiwi, orange, watermelon, and strawberry. So now if I want to remove you, I can use the same thing for discard as well. So let's say I want to, use discard, and then I want to remove dates from it. And let's say I want to print fruit stem. Then what happens is it removes the date. So you might be wondering it sort of does a similar operation, but there's a subtle difference between remove and discard. So in case of remove, if you try to or attempt to remove an item that is not available in the set, like this, for example, then if I try to do that, it's going to throw me an error immediately saying that there is no item called Apple one. What are you trying to do? Basically, that sort of error it would throw. Now, whereas if I try to do the same thing with discard, it's not going to throw me any error. So that's the difference between remove and discard, where in places where you wanna enforce a validation and things, you might as well use a remove. Now we will go to the pop method. Now, pop method just removes randomly, an item from the set. So what I imply by that is like fruits underscore temp. Right now, it's like this. So when I use fruits underscore temp dot pop, it's basically going to remove any item. And then if I simply use fruits temp again, you would see one item got vanished from here. So it was uh, basically orange that got removed. So any random item it would pick and it would sort of remove that from the list. Now there's also one more way in which you would be able to validate if an item is available in the list, and that is using the in sort of operator. So what I imply by that is like in the fruit stem currently we have these three. So if I say if there is kiwi in fruit stem, then print kiwi is yummy, else print no kiwi, no yummy. Yeah. So now with this one, because kiwi was already available in fruit stem variable, set, fruit stem set, it immediately executed and printed that particular one. So if I say kiwi1 here, then obviously it's not going to be a part of that particular fruit set and the temp set, and that's why you see that it is executing the else block and you get it. So in this way also you will be able to verify whether or not an item is available in the set for you to compare. Now, there is also one more thing called as loops. So let me finish the loops and then go back to the frozen set. So for, let's say, fruit in fruits underscore temp, print fruit. So with this way, it's similar to that of iteration, like what we do in tuples, lists, and etc. So we can access the items easily using a for loop with this approach. Now, what I'm going to do is I'm going to move to a section called frozen set. Frozen set is, let's say, fruits frozen is the one that I would like to initialize. Now, let's say I want to initialize it as a frozen set, and then let's say I want to specify apple, and I want to freeze basically banana. Yeah, so this is what I would do. Now, if I print fruits frozen, you can see that straight away instead of a normal set, it is classified as a frozen set. And therefore, if I try to do the similar methods that I try to execute on, like I want to add an item to this set. In this scenario, I want to add kiwi to that set. It's going to throw me in and saying that it's not literally possible. So that's the difference between frozen set and a normal set, wherein if you want to freeze a particular set, and you want to restrict it for certain things where those values are not going to be modify its values are not going to be modifiable or something, then you can choose to use the frozen set. So that comes to the end of the video. I hope you guys like the video. If you like the video, then please do subscribe, share, and give a thumbs up. Thank you.